Hey guys, in this lesson today I'm just going to go over some of the easier concepts from DeMoivre's theorem so that way when we come back from our snow day things aren't too hectic. Alright, so you guys learned on Friday in your groups that when you take a number that is in this polar complex form and raise it to a power, essentially what happens is you take that exponent and apply it to the radius, and you take that exponent and it becomes a multiplier on the angle theta. And this works for any rational number n. Now the examples that we did on Friday only had positive integers. However, this also works on negative integers as well as fractions. When we start seeing fractional n values, that's when we are taking a look at what happens when you take the root of a complex polar number. So basically the process that you're going to go through is if you are given a complex number and it happens to be in this a plus bi form, the first thing that you have to do is convert it to polar, because DeMoivre's theorem only works if you have your complex number in polar form. And recall that polar form is the r cis theta. Once we have it in this form, we can apply DeMoivre's theorem, and then from there, depending upon what the answer states, if it says to put our answer in rectangular or standard form, then we need to multiply it back out into that a plus bi or x plus yi format. If it says that we can leave our answer in polar, then that means we can leave it in r cis theta form. Typically, we will tell you that you can leave your answer in polar when the solutions are not on the unit circle and you would not have a calculator available. If we wanted you to convert your answer into rectangular and you had a calculator available, then you would be expected to use the calculator to find the value that was raised to the power as well as the angle measure. In example 1, we need to first take this rectangular complex number and convert it into polar form. This is what we learned to do the previous day. Pause the video and see if you can correctly convert your answer into polar form, apply DeMoivre's theorem, and then convert your answer back into rectangular. Okay, the first step is converting our rectangular complex number into polar form. Using the unit circle and drawing the point as seen, I can find that the radius is equal to 4 and the angle is pi thirds. So that means that this problem has now turned into 4 cis pi thirds to the 6th power. The first step is we need to apply DeMoivre's theorem, which means that we put the exponent on the radius and the exponent becomes a multiplier on the theta. If we simplify our angle, we see that we have 2 pi, and we learned on Friday that we always want our theta to be in 0 to 2 pi, not including 2 pi, meaning that if our angle is 2 pi, we would actually rewrite it as 0. Now, if we were allowed to leave our answer in polar form, that would be our answer. However, we want you to convert your answer into rectangular. 4 to the 6th power is 4096, so we would have 4096 cosine 0 plus 4096i sine 0. Sine of 0 is equal to 0, and cosine of 0 is equal to 1. Therefore, our final answer is 4096. Now, in some cases, it seems rather tedious to take a rectangular point, convert it into polar, apply the theorem, and convert it back into rectangular. And if we were only raising the quantity to the 2nd or even the 3rd power, that might be correct. However, in this problem, since we're raising it to the 6th power, it is definitely worth our time to convert this into polar complex form so that we can use DeMoivre's theorem. In this problem, we want to do the same thing as we did in example 1. However, notice now that my exponent is a negative integer. The problem will be solved and attacked the same way as the one that we just did. Now here I'm also going to point out that the numerators, the root 3 and the 1, fit nicely with our 30, 60, 90 pattern of a root 3, and 2a. So if you think about this triangle, since it's negative, negative, that means we're in quadrant 3. And essentially what I have is I have my triangle that looks like this. And this is my root 3 over 2, and this is my 1/2. And so this is kind of like my a, this is my a root 3, therefore my 2a is just 2 times 1/2, or 1. And then based on my angle, since I have the longer side horizontally, I know that this is my 30-degree reference angle and theta is 7 pi 6. So I have r equals 1 and theta equals 7 pi 6. If we put this in r cis theta form, we can now go ahead and apply DeMoivre's theorem. Now when I raise 1 to any power, it's always going to equal 1. So this will just equal 1 cis negative 28 pi over 6. And if you recall, we talked the other day that we always want our angle theta to be in 0 to 2 pi. So not only do we have to reduce this fraction, but we also have to make it positive. So negative 14/3, and then we will add 6/3 3 times until we get into a positive angle. And we find out that this is equivalent to 1 cis 4 pi thirds. And then again, final step, we need to convert this answer back into rectangular. So we will have 1 cosine 4 pi thirds plus 1i sine 4 pi thirds. And if we plug in those unit circle values, we get negative 1/2 minus root 3 over 2i. This next problem is one that we will do in class in our lesson. However, if you wanted to try it now, the answer at the very end is negative 1 over 32 plus I root 3 over 32. The next area of DeMoivre's theorem that we're going to talk about is when we take roots. And a root is going to occur when we take a fractional exponent. So all non-zero complex numbers have what are called p-distinct p-th roots, which I know sounds extremely weird. For example, if we're taking a square root, that is a second root, and there are 2 of them. If we are taking a cube root, that's actually a third root, and there are 3 of them. A fourth root, there are 4 of them, and the pattern continues. So if we are taking a p-th root, then there are p roots as answers. Now, we typically don't talk about these because a lot of the roots are not real numbers. So in order to find them, what we're going to do is we're going to use DeMoivre's theorem. First, if the number that we are asked to root is rectangular, then we're going to have to convert it into polar form. And we have to do that because the DeMoivre's theorem only works if we are in polar form. Once we are in polar form, just like we saw before, we can apply the exponent on the r, and it becomes a coefficient on the theta. Now after we go ahead and apply DeMoivre's theorem, the first root is called the principal root. And for the principal root, the angle can be between negative pi and pi. And I know this is a little confusing because in all other areas we want our angle to be between 0 and 2 pi. Once you find this first root, it's kind of like your starting point. And the roots are going to be equally spaced around the unit circle. Or I guess we could just say around the circle. To get the other roots, we are going to use 2 pi divided by p to find the spacing. And this should remind you of how we did our rose graphs. Recall with our rose graphs, we would find the location of the first petal, and then we would do 2 pi divided by the number of petals to find the spacing. This is the same idea. We do DeMoivre's theorem to get the first root, and then we do 2 pi divided by 2 to find the subsequent angles for the next roots. All of the roots are going to have the same r, so the only thing that changes is the actual angle. Let's write that down. All roots will have the same r. The only thing that changes is the angle. Okay, so we're going to go ahead and just take a look at 1 or 2 problems like this, and then we will finish the rest of the examples in our lesson the following day. Okay, now when you look at this problem, there are a couple of things that should jump out at you. First of all, the term that is in the radical is rectangular. And in order to do anything involving DeMoivre's theorem, we have to first convert that to polar. The next thing that should jump out at you is that we are taking a fourth root. So if it's a fourth root, then we are going to find 4 other roots in total. So the principal root and then 3 more. Alright, so if we were to go ahead and convert this into our cis theta form, remember it's purely imaginary, which means it's on the positive y-axis. Therefore the radius is 16 and the angle is pi halves. And a fourth root is the same as a 1/4 power. Now that we have it represented this way, we can go ahead and apply DeMoivre's theorem. 16 to the 1/4 power is 2, and then I'm going to multiply 1/4 times pi halves, which gives me pi eighths. This right here is what we call a spelling error. This is called, oh geez, the principal root. If we were to visualize this in our complex graphing area, and let's say this was a circle of radius 2, and pi eighths would probably be right about here. That is our first root. Now to get the rest of the spacing, we have to take our full circle and divide it by 4, which gives me pi halves. So what I'm going to do is I'm going to add pi halves 3 more times to get the rest of the angles around the circle. So if we look at our roots, my first one is 2 cis pi eighths. All 4 of the roots are going to have the same radius. So they're all going to start with a 2. And they'll all have the cis in there. Alright, so now with my angle I need to add pi halves, which is the same as adding 4 eighths. So my next angle will be 5 pi eighths, 9 pi eighths, and then 13 pi eighths. Now if we visualize these points around the circle, 5 eighths is a little bit bigger than half, and 9 eighths is a little bit bigger than pi, and 13 eighths is just a tad bigger than 3 pi halves. And you can see when you look at these that they are all evenly spaced around the circle. Now if the problem doesn't say we can leave it in polar form, then we have to convert it back into rectangular. And converting it back into rectangular for this problem would require a calculator. For example, to find the first root, what I would type in would be 2 cosine pi eighths plus 2I sine pi eighths. All 4 of these answers are going to be decimals. Go ahead and find all 4 answers and then check your solutions with the video. Again, I want to stress that all of these answers start out with the same radius. After you applied DeMoivre's theorem once, then you find the spacing between the roots, which is found by doing 2 pi divided by the number of solutions that we have. For this problem set, we're going to do all of the steps we did in example 4. However, we're just going to leave our answer in polar rather than having to take the calculator out again to solve the problem. Go ahead and convert your answer into our cis theta form and try and apply DeMoivre's theorem. When you think you have your correct answer, replay the video. In this problem, the area that people typically struggle is trying to figure out how to do the 2 root 2 to the 1/3 power. So I'm going to kind of work off some algebra off to the side. We could think about this a couple different ways. A 1/3 power or a cube root is looking for 3 of a kind. So you can think of 2 root 2 as 3 cube or square roots of 2. Therefore, the answer would just be root 2 when you're looking for a cube root of it. That's one way you can think of it. Another way you can think about this is we can represent 2 root 2 as square root 8 and raise it to the 1/3 power. And 8 is 2 to the 3rd, so this becomes 2 to the 3rd raised to the 1/2 power raised to the 1/3 power, and the 1/2 power comes from the square root that is on the 8, and if we multiply all those together, we get 2 to the 1/2. So there's a couple different ways that you can think about it. Regardless of how you approach it, I do expect that you can algebraically understand that 2 root 2 to the 1/3 power is root 2. So we get our first principal root to be root 2 cis pi 12ths. From there we have to get our spacing. Recall that the spacing is always found by taking your full circle of 2 pi and dividing it by the number of roots, which in this problem is 3. So that gives us a spacing of 8 pi 12ths. And I wrote it in terms of 12ths so that I would have like denominators with my pi 12ths initial angle. So all of my roots are here in purple, and when I write my final answer, I would definitely want to reduce those angles. So for example, here I would write this as 3 pi 4ths. One final way that you can double check yourself is by graphing these angles. So root 2, if we were to draw a circle, which is kind of approximating where root 2 is at, for the angle of pi 12ths, that would be really tiny. The angle of 3 pi 4ths would be right about here, and 17/12ths is just inside of the 3 pi halves. And if we look at those three angles, we can see that they are definitely evenly spaced around the circle. Alright, this is where we're going to start the following day in class, and basically what we're going to do is take a look at how we can isolate the variable that's being raised to a power. So in this case, for example, we would have x cubed equals 8, and we can then cube root both sides, giving me that x equals the cube root of 8. And if we want to find all solutions, then what we're really asking you to do is to treat the 8 as 8 plus 0i, convert this into our cis theta form, and then apply DeMoivre's theorem. And this is where we're going to pick up with next day in class. Alright, enjoy your, oops, goodness, can't even spell. Good thing I'm a math teacher. Enjoy your snow day, and help your parents. Don't make them take care of all the snow. All right. Good night.